5.2 is solving systems of 3 equations. Essentially, what's going on in this section is instead of having 2 variables and 2 unknowns, we're going to have 3 variables and 3 unknowns. And one of the things that you're going to have to do is, and we did this with the systems of 2 equations, when we had to verify if something was a solution, the biggest difference is that instead of having just an x and a y, now for a system of 3 equations, you're going to have an x, a y, and a z. So it's considered an ordered triple. And so in order to verify that a particular ordered triple is a solution, it has to work in all 3 equations. So you're going to have to plug it in and test them out into all 3 equations. And if they work in all 3 equations, then it's a solution. If it doesn't work in one of them but works in the other 2, it's not a solution. Okay, it's got to work in all 3. And so you're going to have some problems where you're going to have to do that. In terms of a visual, here's kind of what we're talking about. You don't need to take a picture of this. I just want you to see this. Okay, but this is 3 dimensions. So, yeah, this is the world we live in. Correct. So when we were looking at systems of 2 equations and we were having just the xy plane, it was flat and it was just up and down and right and left. Now, if you wanted to, you could kind of think of like an axis coming at you. And so that's what this z-axis is. So this is so the blue one here is our sort of normal xy plane, but then the z-axis, it kind of comes out at you. So that's, in theory, you could have a point that has an x and a y and then comes out toward you or away from you, if you wanted to think about it that way. Just kind of tying it all together, how we look at an x and y plane and a point and where it fits. We're not going to draw this, but I just wanted you to understand that this actually exists. Okay.
Class, 5th or 7th period?
So let's keep moving. Okay, so here's what we're going to be doing. Okay. You're going to use elimination or addition, however you want to call it. And we're going to take our system of 3 equations and we're going to get it down to 2 pairs of 2 variable equations. So essentially what we're going to do is we're going to take 2 of the equations and eliminate 1 variable. Okay, then you're going to pick 2 other equations and eliminate that same variable so that we get it down to a system of 2 equations with 2 variables. That's what our goal is. Okay, get it into something that's a little more manageable. So you're going to take 2 of the equations, eliminate 1 of the variables, and you're going to get 1 equation with 2 variables. Then you're going to do it again and get a different equation with 2 variables. And then you're going to have that. That's what when I say that new system of 2 equations, that's what I'm talking about. Okay? Then you're going to solve that new system. And so what that's going to allow us to do is get 2 of the variables. Right? So let's say it was x, y, and z. So in this case, I solved my new system that only had 2 variables, so then I can solve for x and y. And once I do that, I can plug it back into one of the original equations and get z. Or whichever variable you have left. The last step is then take those 2 variables that you found in the green, number 2. You're going to plug those back into one of the original equations to find the 3rd variable. Let's look at a problem. So here's kind of what we're talking about. So 3 equations, 3 variables. The key thing is understanding that no matter how many variables you have to have at least that many equations in order to solve. So when we were doing systems of 2 equations, we needed 2 equations to solve for 2 variables. When I have 3 variables, I need 3 equations, like we have here. Okay. So what our mission is from the very beginning is to make a decision about which variable we want to eliminate first. Because we've got to get it down from x, y, z to, let's say, x and y, or x and z, or y and z. Okay, but we have to make a decision right from the beginning which variable you want to eliminate. And I would analyze it a little bit and say, look, is there one that seems easier to get rid of than another that will require that I do a little bit less work? because these problems do take a while. And if you remember, for those of you who had me a couple years ago, that a problem like this, there was one of them, and it was the entire page. I left you the entire page to work on that problem. And so what can happen with these problems is it can take up a lot of space, and there's a lot of steps, and so you want to try to minimize your steps whenever you can. And so here's how I would do my analysis. Okay, I just start with the x's because they're first and go, all right, are any of these multiples of each other? Could I get by with just multiplying one to eliminate without having these fractions? And I mean, if I wanted to eliminate these, I'd have to multiply both equations, right? If I wanted to eliminate these, I'd have to multiply both. If I wanted to do the first one and the last one, I'd have to multiply both. So right away, I'm sort of shying away from the x, thinking, nah, I don't know if I want to do that. So then I slide over to the y, and I go, oh, okay. This y right here is going to make my life easier. Because if this was a 2, it would cancel with this. At the same time, if this was a 3, it would cancel with this. So I can minimize the number of moves in order to eliminate the y's. And then I slide over to the z's, and I have the same issue that I had with the x's. I'm going to have to multiply both equations in order to eliminate the z's. So what I want to do, based off of that analysis, is eliminate the y's first and create a system of equations that only has x's and z's in it. That's how I'm going to approach this problem. Now, there are going to be some problems where you can't avoid multiplying both, and you're just going to have to pick one and off you go. But when you can save yourself some trouble, you might as well. So that's what we're going to do, is eliminate one variable, and as I just discussed, I'm going to eliminate the y's. So what I'm going to do is I'm going to pair the top two equations together and eliminate the y's. Then I'm going to pair the bottom two equations together and eliminate the y's. So that's what it kind of looks like here. So this one is, let's see, that's the top one. And then let's color code them, sure, why not? Here's the middle one. And then here's the bottom one. So that's how I've kind of paired them up. I put the green and yellow together, I'm going to eliminate the y's. I put the yellow and blue together, I'm going to eliminate the y's. And some of you guys will like to number your equations instead of color coding, which is fine. And maybe you make, this one equation 1, equation 2, equation 3. Some of that kind of stuff that sort of helps you keep organized is going to be important. So on this first pair over here, what am I going to have to do to eliminate the y's?
Multiply by 2.
Multiply what by 2?
The entire equation.
Which one?
Bottom.
The bottom. The yellow equation. Let's just multiply that all by 2, and then the y's will go away. What about over here? What am I going to have to multiply by?
3.
Which one?
The top.
Top equation by 3, and then the y's will go away. Here's where I'm at. Okay, so on the left, I multiply by 2, and so I'm going to get this 3x minus 2y plus 4z equals 35 is still here, and then the bottom is where I get my multiplying by 2. Right? So then I just have to combine those. The y's go away, and I'm left with an equation that just has x and z. Okay? You guys told me on the right to multiply by 3. Same idea. Okay, so that top equation times 3, the bottom equation stays the same. Over here, so we're set up so that the y's will cancel. Now I just got 3 minus 8x, 3x minus 8x, so that's minus 5x. I've got my minus 6z, and that's going to equal, what, negative 30. Okay, and then over here my y's cancel, so I have negative 7x minus 12z equals negative 77. So what I've done, what we've accomplished, is getting it down to 2 equations with 2 variables. So I'm going to flip over to the next screen, and you're just going to see those numbers again. So the bottom numbers are going to be on the screen again. There they are. Okay, so there's those bottom numbers. So now what I need to do is bring them together and solve that new system. Okay, so I want you to do that, please. Okay, if you lose a sign somewhere, you can create an unbelievable amount of pain for yourself. Okay, and here's what's important, because your test that's coming up on Friday is going to be a class kick test. So all your steps that you would typically show, you will still show. Okay, and what I would prefer that you do, instead of just completely abandoning a problem, is continue to follow it through. Now, your gut is going to tell you somewhere along the way that I'm probably making a mistake. Maybe I should back up from where I am now and recheck my signs. Did I write the problem down right? Did I add correctly? That kind of thing. But if you can't find it, don't just abort. Keep going with it, because let's say you did that and you lost this sign and everything else was right. What you're proving to me is that you understand the concept, you know what you're doing, you made a mistake. It's not going to kill you, but you're communicating to me that, look, I understand what I'm doing. I know how to do this, I've learned the concept, and that's what I'm most, that's the thing that's most important to me, that you understand what you're doing. Now, will I take some points off? Sure. But a problem like this, where there's so many different steps, there's so many different points available, that one little step's not going to kill you. Okay. So in this case, what you should have gotten, x and z, x is -1 and z is 7. Okay, how many got those two? Okay, good. Okay. The same way we got them before. So once you find your x, plug it back into one of those two and find z. Now, what I have to do next is to find y. So you have to pick one of the original equations to find y. I would use that middle one again, since it already sort of has a y by itself, and plug those in for that. Some cases it's not going to be as easy, and you're going to have a little more work to do, but either way you can plug it in. Like I said, I'm going to pick that middle one again. So I plug my -1 in for x, my 7 in for z, and then I just have to simplify all this and get y by itself. Okay, so then to get y by itself, this is just 4, this is -35, and then get the y by itself. I'm going to simplify, so that is giving me -5. Now, what's important too is to understand, like we talked about before with systems of 2 equations, you express your solution as a point. You're still going to express your solution as a point. It just happens to be that it has 3 coordinates now. Okay, and so my final answer for this is going to be -1, -5, 7. And it is going to take you some time, but that's why I also didn't assign you, too many problems. I think you have about 8 problems or something like that total, and some of them are verify that this is a solution. Okay, so they're not too bad. You do have your review on top of it, but at this point you have an hour to work.
Wait, how do we know if it's not a solution?